Eddy currents are loops of electrical current induced within conductors by a changing magnetic field. When a magnetic source moves near a conductive metal, it triggers a flow of electrons in a circular pattern, much like swirling eddies in a river. According to Faraday's law, any change in the magnetic environment of a coil of wire or a solid conductor will cause a voltage to be induced. In solid plates, this voltage creates the circulating currents we call eddy currents. Lenz's law tells us the direction of these currents. The eddy current creates its own magnetic field that opposes the motion of the magnet that created it, acting as a form of invisible friction. This opposition is used in magnetic braking. As the metal wheel spins through the magnetic field, eddy currents create a drag force that slows the wheel down smoothly without any physical contact or wear. Because conductors have electrical resistance, eddy currents transform kinetic energy into thermal energy. This process, known as Joule heating, causes the metal to warm up as the currents flow through it. Induction stoves use this heat. High-frequency alternating current in a coil creates a rapidly changing magnetic field, inducing eddy currents directly in the bottom of the pan to cook food efficiently. In transformers, eddy currents are often unwanted because they cause energy loss. To prevent this, engineers use laminated cores made of thin insulated sheets, which break the paths of the currents and reduce their strength. Metal detectors work by sensing the magnetic fields produced by eddy currents. When the device passes over a conductive object, the induced currents create a secondary field that the detector identifies as metal. In aviation and manufacturing, eddy current testing is used to find invisible cracks. A flaw in the metal interrupts the flow of the currents, causing a measurable change in the magnetic field that reveals the damage. Recycling centers use eddy current separators. While plastic is unaffected, the currents induced in aluminum can create a repulsive force that literally kicks the metal off the belt into a different sorting bin. Sensitive laboratory scales use eddy currents for damping. By creating a small drag force on the moving parts, the currents stop the needle from swinging back and forth, allowing for a quick and accurate reading. From braking trains to cooking food and sorting trash, eddy currents are a powerful application of electromagnetism. They demonstrate how changing magnetic fields can influence the physical world through induction. Generated by Vision Solve AI.